So this is part 4 of chapter 23. So now for this one, we're going to focus on how does natural selection bring about the adaptation to evolution. Adaptation of evolution, adaptive evolution, I guess. So, excuse me. So before we do that, we're going to talk about a little bit about fitness. The contribution an individual makes to the gene pool of the next generation. That's what we meant by fitness. And since now we defined fitness, we're going to talk about how natural selection help alter the frequency and then different heritage of traits that's passed down to the next generation. So there are 3 ways that natural selection can do so. One is what we call directional selection. Okay, next one will be disruptive selection. And the last one will be stabilizing selections. Okay. Now, using a graph to represent these 3, we can see that right here, we can have a normal population that looks like this. You have most of them that's in the mid-range, the phenotype, and then you have the more extreme cases with a much lower population size. So now, from this original population, we could have a directional selection, which means that in this picture, it shows that from the normal, from the original, you have going to this dash shaped evolved population, which actually eliminate the white mouse almost completely, because there's none right here, and with very little, but it's not really shown, this much lighter brown color mice. Okay, that's what we call directional. So we have one direction, it moves one direction, not the band. We going towards the right, that one directional shift. It could go to the right or it could go to the left. It doesn't have a specific one, but it usually will be one way or another way. Okay, next one we can go to is disruptive selection. So what we have here is we usually have a normal curve with a lot of population in the middle, but disruptive talks about you now have 2 much higher distinct group. Okay, so imagine this is separating, okay, into 2 groups, 2 camps. Okay, so now you have population of the new population, the disruptive selection will have a white mice population, and then the dark fur mice population. Okay, that's what disruptive selection is. And last one, stabilizing selection. So stabilizing selection, excuse me, would have a very narrow zero-in effect on a population. So it will select a very specific type from that population. So for these examples, you can see out of the 5 different colors, only the medium brown is survival. It's the last population representative. The rest of them has been eradicated or has been somehow removed from the population. So that's what more stabilizing. So think about stabilizing into just one or few, a small, very small, narrow range of a population range. So besides natural selection, the different selections that I just mentioned, we also have sexual selection. And from natural selections, we will have sexual selection. It's more talking about certain individual would more than likely obtain mate than the others. Okay, and from sexual selection, we have a phenomenon called sexual dimorphism. Sexual dimorphism talks about the male and female has very distinctive, whether it will be size, color, and any other things. Okay, and then I just list a few of them right here. But the sexual dimorphism talks about the 2 sexes have very drastic different behavior, size, color, etc. Okay, so like you can see right here, peacock. The male is has a really large tail, versus the female has very small in comparison tail. And then the lion, you can basically spot which one's male, which one's female. This one's male. No, I'm just kidding. This one's male, and this one's female. Okay. So a sexual dimorphism of their physiology is very, very pronounced. Furthermore, from sexual selection, we have intrasexual and intersexual selections. Intrasexual selection is talking about the same sex competition. Usually it talks about male competing with male or female competing with female. So, for example, if two male birds trying to mate with a female, they will have to first compete with each other, and then whoever is the winner, then the female will select. Okay, that's intrasexual. Intersexual is talking about different mate choices. And an example that I give is the female would probably pick the more showy male between the two birds. So whoever is coming to, trying to please the female, trying to get the vote from the female, they will actually, for example, dance in front of the female, and the female, which is out of all this competitor, she will pick one that's the most showy, the most highly skilled dancer, etc., etc. So that's intersexual. Furthermore, we have interesting phenomenon that sometimes organism will actually preserve genetic variation. So right here, diploidity, it's basically a phenomenon where we hide the recessive alleles that are less favorable. Okay, so when we hide that at the time, it will not be pronounced. Therefore, it will not be likely to be passed down. Okay, and when that happened that time, even when it's passed down, it would not be obvious. Okay, so one thing it's about evolution is we need to talk about something special called heterozygote advantage. So we actually find a greater fitness of heterozygote than homozygotes, and an example of that would be sickle cell disease. So what happened is that within this region of Africa, we have African who are mating with Africans, which is natural because they're in the same continent. And when they are mating within close range, what they have is they actually have the allele type that creates a red cells that is actually sick looking, and it actually looks like this. So because of structural differences, it is not able to carry the oxygens, so which causes the disease of sickle cell. So what happened was, because of that recessive genes they have, two of the recessive genes combined together will cause and will lead to the sickle cell disease. And then versus if the person only has one recessive gene and then one dominant gene, then this disease can be avoided for the reason that the dominant gene will be expressed rather than the recessive genes. So natural selection actually cannot fashion perfect organism. Okay, and these are the reason why. Number one, selection can act only on existing variation. So you cannot create a superpower organism out of nowhere. The superpower has to be existing within the population already, and natural selection would choose that over the other one. So it cannot invent something that doesn't exist. It can only select whatever it's already there. Number two, evolution is limited by historical constraint. And then number three, it's adaptations are often compromises. So sometimes the adaptation doesn't actually express fully in the sense of like, I don't know, perhaps using an example would be like, okay, let's say all of a sudden I have a special power of being able to read much faster. But with that, adaptation would not be at its full-blown potential. Okay, that's not a very good example, but basically adaptation would not be able to go for the full effect. It's usually compromised because due to the genetic variation. And number four, chances, natural selections, and environmental interact. So because natural selections it's based on chances, and natural selections are often environmentally caused or yeah, environmentally driven. That's the word I was looking for. So it actually cannot be cannot shape a like superpower organism. By superpower, I mean like any like extra crazier strength. Okay, and then this is sample problem. Just kind of talk about different directional, disruptive, and stabilizing selection, so you can have a better understanding of the these three. So A is tiger cubs usually weighs about 2 to 3 pounds at birth. This is what we call a dramatic pause, stabilizing selection. Okay, and the reason why it's you might have tiger cubs that's born at 1 pound or 5-6 pounds, but in general it will be narrowed down to 2 to 3 pounds because that's probably the most favorable weight. B, butterflies in 2 different colors each represent a species distasteful to birds. This one will be dramatic pause. This one will be disruptive. The key word that you will be looking at is 2 different colors. So it actually has a 2 extreme end to it. So this one will be a disruptive selection. C, brightly colored birds mate more frequently than drawn birds of the same species. This one will be dramatic pause. This one will be directional. Well, because the birds are specifically chosen, well, there will be a selection between the birds that specifically choose the colored bird much more favorable than the non-colored bird. So this one will be all shifting towards the colored bird. That's why directional. D, fossil evidence of horses' size increasing over time. This one will be dramatic pause. Directional as well, because you can see that the horse size didn't increase and decrease, but it increased. So it's shifting towards a specific side of a selection. So hopefully you understand more about how evolution within population is occurred, and then some of the natural selection will help you to see how adaptive evolution occurs within the population. Okay, if you have any question, please let me know. Otherwise, see you next time.